Hello students, good morning, good evening and good night. That is basically depends on which time you are going to observe this lecture. Welcome to the second lecture on the electrochemistry chapter. In this lecture we will basically focus on three aspects. Number one, we will discuss how to represent a cell. How to represent a electrochemical cell. The three aspects that we are going to discuss in this lecture. First, we will discuss how to represent the electrochemical cell, how to measure the cell potential, number three, how to measure the electrode potential. The three things that we are going to discuss. This is K.K. Mukherjee in the Science with Mukherjee Sir YouTube channel. In the previous lecture, lecture number 1, we have discussed about the basic construction of a electrochemical cell. That we have observed one very basic thing, that redox reaction has been splitted into two parts. That is, in one part that there is oxidation going on, in the other part there is a reduction is going on, that is separately. And the oxidation, where the oxidation is going on, at that portion we will call the cell, that is the anode. And we have also understand how a potential is created due to the electrode and the electrolyte interface. There is a potential is created. In case of anode, you will find that is electrode has been negatively charged, and this potential we call, that is the negative potential, or it is called oxidation potential. In the other part of this galvanic cell, there is this is another half cell reaction that we see, that is the reduction reaction, where you will see it is called the cathode, and at that portion you will find that is the positively charged. The electrode has been positively charged with respect to the electrolyte, and the potential has been created between the electrolyte and the electrode, and this is called the reduction potential. So two type of potential we understand, one oxidation potential and another reduction potential. Now we discuss how to represent a electrochemical cell. It is a convention as per IUPAC. When we are going to represent the electrochemical cell, we have to first, in the left hand side, that we have to left hand side of the representation, we have to put the anode. In the right hand side, there will be a cathode. And how to represent that, let us understand. So it is a general term that you have to give the metal, and between the metal and the electrolyte solution, that is the metal solution, metal ions we can say, metal ion, and it is being represented by its physical state, that is aqueous state, and the concentration of the metal ion, that is C1. And there will be the vertical, here one vertical line is being put between the metals and the electrolyte. Metal, and this is basically the electrolyte solution that we have written here as a metal ion, and it is the metal that is one electrode. And the concentration of this metal ion that we have to written, and this is been separated by a vertical line, single vertical line, and there is a double vertical line we will put between the two electrolyte solution. That is, this is metal ion 1, and here also you can see that we have to write the metal ion, and we have to write this physical state and also the concentration and then the metal. In this part is anode. Here the oxidation is going on. Oxidation is going on, which is the oxidation half shell, we can say, and this is the another half shell. Here this is called the cathode, and here the reduction is going on. So left hand side you have to put the anode, you have to put the electrode, then you have to put the electrolyte solution, the concentration of the electrolyte solution, and metal ions of, after this there is a double vertical line. This represent the difference between, separation between the electrolyte solution and also the salt rich, and here is also the metal. Now this can be easily understand if we take one very basic example, that is the Daniel cell. We know the Daniel cell, that is, you can see the reaction is going on like this, that zinc plus Cu2 plus, then Zn plus 2 plus Cu. This is the rate of reaction going on, and this reaction can be split into two parts. One, that is the anode, that you can see, that is two parts that you can see. This is oxidation reaction. The zinc has been oxidized into the zinc ion and it liberates 2 electrons, and this is the anode, the reaction at the anode. And here copper plus 2, it will accept the 2 electrons and it will, copper is deposit into the copper rod, and this is the cathode reaction. So this cell where this reaction, that is the Daniel cell, is going, this reaction is going on. So we will represent this like this. First we have to see the metal. Metal is Zn. Yes. Then we have to write the metal ions, and we have to write this physical state, and this concentration of this ion we have to write, then double vertical line, and you have to put here, that is copper plus 2 aqueous and its concentration, and then copper. And this is the representation of the Daniel cell where this redox reaction is going on, and in the, this is the anode and this is the cathode. This is anode and this is cathode. So it is very simple, there is no such complexity in it, but there are different types of questions that may come from this representation of the cell, that is we are discussing now. Which type of question comes, let us understand. This is the reaction, and from this reaction you have to say, the option is given here. in which galvanic cell, this is the cell, this one cell, this one cell, one cell. You have to say in which cell this reaction happened. For that, what you have to do? You have to see the anode reaction and the cathode reaction. Means where oxidation is occurred and where reduction is occurred. So for that, we have to see from this reaction. First, we will see the anode reaction. Anode reaction, that is oxidation reaction. Okay. Oxidation reaction. Here you can see which is oxidized. Hydrogen is oxidized because its oxidation number is increased from 0 to 1. So here hydrogen is oxidized. So we can write this reaction, hydrogen this is the oxidation reaction. In the reaction happened in the anode half cell. And another reaction, that is reduction reaction, is this. This is the cathode reaction. So this is the oxidation reaction of anode. This is the reduction reaction occurred in cathode. So now we know when we are going to represent the cell, first we have to write the anode. In the left hand side there is the anode. In the anode this reaction is going on. So what we write? You have to write a electrode because hydrogen is a gas. For that you need a electrode. That is, we have taken here platinum. Here platinum is here. So platinum electrode is there. Then we have to write the hydrogen gas, and then we have to see the HCl because here H plus ion has been created and Cl minus ion has been created. So we will write the HCl aqueous. Then that is this you have put this double vertical line, the single vertical also this, and then you have the cathode reaction. That you cathode is here AgS. Cathode reaction, what is going on? That first we have to write the AgCl. In the cathode AgCl, then the product is AgS, silver. So this will be the representation of cell as against that reaction. This reaction is goes on carried out in this galvanic cell. So here you can see B is the right answer. Okay. Now here you have been given the reactions. Now sometimes what will happen, you have been given the cell itself and you have to say which reaction will going on in that cell. So now we are going to discuss this. The cell is given here, suppose. Sorry, here it will be, that is wrongly mentioned, that is C. Because we have discussed this is a So this is a cell, and from this cell we have to say which type of reaction is going on. That is, the option is given, number 1 option, that they cannot determine. Cannot determine. first option. Second option is going, that is which type of reaction is going on in that cell. That option is given, that maybe you cannot able to determine it. Maybe it will be second option, maybe third option, or maybe fourth option. That what is the options? For that, when this type of question come, that you have to, the cell, when cell is represented, at the left hand side of the cell there is the anode. So you can easily say about the anode reaction. What is the anode reaction here? You can easily say that A is oxidized. In the anode, oxidation is going on. So this will be the reaction in the anode. And in the cathode, the reduction is going on. This is the cathode reaction. So it will this, it will accept the electron, it is reduced, and it will possess this. So overall, you can see this reaction, that is A plus B charged, and A plus A. This will be the reaction in the cathode cell. So what will be the answer? The answer will be the second one. So we understand how to represent the cell and which type of questions come in that from this concept. Okay. Potential. We can now understand a cell is composed of two portions, one anode and another is cathode. In the anode there is a potential difference created, that is called the oxidation potential, and the cathode a potential created, that is the reduction potential. So we can write, suppose E potential of the cell is this E cell. So you can write this is equal to oxidation, OX means oxidation potential, that is here oxidation is going on, plus E reduction, where reduction is going on, means this is a cathode and this is the anode. Reduction. Now this is a convention as per IUPAC. You have to always remember in your mind that whatever the potential we have to, whether it is electrode potential or the cell potential, it must be the reduction potential, not oxidation potential. So what we are going to do, we have to convert this oxidation potential into the reduction potential. Then what will be the conversion? That only the simple thing, that magnitude will be same, but their sign will be different. So we can write this E reduction minus E reduction, because here this is the oxidation, where the oxidation is going on at that portion, the reduction potential is this. So you can write here reduction going on here, reduction, that is, and here oxidation is going on. But we convert this oxidation potential into the reduction potential, that is why this minus value is come. So we can write this E cathode minus E anode. Electron potential in the anode, and this is the reduction potential. In the anode, basically oxidation potential is there, but we have to, as per the system, that we have to follow that system. So we have to write this reduction potential. So further we can write in respect of the galvanic cell, that we have always on the previously we have discussed about it. That is, in the left hand side there is a anode, in the right hand side there is a cathode. So we can write E RHS minus E left. So this is the cell potential. That potential of the cell is basically difference of the electrode potential, that is the reduction potential between the cathode and the anode. So we can write what is the cell potential. We can write this cell potential is the difference of electrode potential that is between the cathode and anode. Okay, so we understand the cell potential is nothing but it is a difference of the cathode potential at the cathode and minus potential of the anode, and that is the reduction potential. The potential we are talking about, you have to always remember that is reduction potential, not oxidation potential. Reduction potential. So we can write this, we can understand that what is the cell potential. It is very simple, that is the difference between the cathode, difference between the electrode potential at the cathode minus electrode potential of the anode. One reaction I am giving that for the question, this quarter question will come. Suppose we have given one reaction, Fe plus Fe3 plus, that is charged, and it will produce Fe2, 3. You have to say what will be that this is a electrochemical cell and what will be is cell. Cell potential. What will be is cell potential. And you have been given the two electrode potential. This electrode potential are, that is given this data, that is the cell potential, electrode potential, to calculate the cell potential. So for this type of question will come, what we will do? First we have to write the oxidation reaction and the reduction reaction. For oxidation reaction, you can see here Fe is oxidized to Fe2 and it will liberate 2 electrons, and Fe3 plus is reduced to Fe2. You have to multiply 2. Okay, so what is the reaction? The reaction is here it is will be 2. So this reaction will be this. So you can see Fe plus 2 Fe3 plus is equal to 3 Fe. Now you have to construct the cell potential. E cell equal to E right hand side minus E left hand side. So here you can see this is the anode and its electrode potential, that is given minus 0.441. This is the cathode, its electrode potential is given 0.77 voltage. So now you will be able to calculate. EIHS is given 771, that is the cathode, minus 1441. So if we calculate it, it will coming as 1.22. So this will be the answer. Okay, this will be the answer. So for that, what we will do, we have to first make this. We have to from this reaction we have to produce the cell, and after this cell, that we will after with this formula we will get this voltage. Because it is not possible to measure individually the potential of a half cell, because half reaction never occurred alone, because it always occurs simultaneously, one redox reaction and one reduction reaction and one oxidation reaction. In the oxidation, electron is released and that electron is accepted by the reducing species. So alone you cannot able to calculate the cell potential, but if you choose arbitrarily the half electrodes, that is half cell of the potential of the half cell, if you arbitrarily choose it, then you can able to calculate the potential of the other half cell with respect to this half cell. And in that regard, one cell, standard cell, half cell has been designed. This is called the standard hydrogen electrode. Standard hydrogen electrode. This half cell is called the standard hydrogen electrode, and it is represented by this. This is represented by this, and its half reaction is represented by this. This is his half reaction, that is the reduction reaction, and the cell is this, and the constitutional cell is like this. This is the platinum electrode. Platinum electrode, and it is coated platinum electrode, and it is coated with the black platinum, finely grinded black platinum. It is coated, and here you can see there is a solution of 1 molar HCl solution, 1 molar HCl solution, and the pure hydrogen has been bubbled through it. So this is the SHE, that is the standard hydrogen electrode. And this standard hydrogen electrode, the potential of this electrode is zero. Potential of standard hydrogen electrode is 0. And this electrode, when we are going to measure the half cell of the other half reactions, that when we are going to measure the potential of this other half reaction, then we have to put this oxygen hydrogen electrodes, standard hydrogen electrode, at the anode. So you have to construct this cell, that is hydrogen standard hydrogen electrode, then the half cell. Then we have to put this half cell, and this half cell we can able to calculate because we know the standard hydrogen electrode having the potential having the 0. So we know here, we know the potential E cell, and here what is going to happen, we have to put all the species at the standard conditions. You can see hydrogen, it is put as 1 bar pressure, and here the ion, the concentration of the HCl, the H plus ion is 1 molar. So when it is at the standard state and the half cell also in that standard state, at that time what is going to happen, the potential of the cell itself is the electropotential. How? See, that is the standard hydrogen electron, that is in the anode. Here it is put in the anode and it is put in the cathode. Now we calculate is, we know the cell E cell, we know because we can able to calculate it. We can able to calculate the difference of the electropotential, but we do not know what will be the potential, electropotential individually. But we know E cell, then what will put, that will be E cathode, we know E cathode minus E anode, that is the cell potential. So when we put this E cathode we can even calculate this E cathode, but E anode we know already, that is a 0. So E cell is equal to will be E cathode. And that way we can able to calculate the potential, electropotential of this half cell by knowing the E cell of this total cell. So in this way, all the electropotential that we will discuss in the next lecture, that electrochemical series, so all the electropotential of any individual half reactions has been calculated with reference to this standard half cell, that is standard hydrogen electrode. That is all for today's lecture, and I think you understand all the points that I am trying to discuss. And if you have any doubts, you can comment in the comment section. That is all. Thank you for watching this lecture. Thank you.